Assalamu alaikum guys, welcome back to Civil Engineers YouTube channel. Today I am on this construction site. We'll guide you for steel reinforcement details in the construction of this RCC slab. They did some common mistakes, so let me point out those mistakes in front of you. Also I will guide you for some technical terms in the construction of this steel reinforcement. So let's get started guys. If you have any question related this short video, so you can comments, I will try to reply your answer. Guys, you can see this is shuttering, and the shuttering work is about in completion. Okay, they used in this shuttering ply. Okay, so this shuttering is made of ply which thickness is about 10 millimeter. Guys, you can see this is 10 millimeter thickness of ply. Each sheet size is 4 by 8 feet. Okay, 4 by 8 feet is the size of ply. Guys, you can see the joint between each ply. You can see they use the plastering tape on the top of this. So this is very important, and this is the technical terms of construction site. Okay, so if the joints are open, as you can see like this, so used plastering tape on the top of this already they did. So this is one of the important point. Guys, you can see here the span between each the span between these two columns is about 14 feet. Okay, it means so they used the steel reinforcement for this section about 14 feet. Already they did one of the big mistake. Guys, you can see in 14 feet they will provide here lapping. Okay, so this is not the proper steel reinforcement design. That's why, because of this steel reinforcement is about 40 grade. Okay, so this is 40 grade. It means so we have 40 feet length, so they should provide 40 feet longitudinal bars, if that is main bars and distribution bars. Okay, so they should not making the cutting length of this steel reinforcement about 14 feet. So this is not the proper design. That's why, because they will provide the lapping here, again they will provide lapping at this place. Okay, so this is not good. Okay, so what is the proper way? So they should place the 40 feet steel reinforcement. Okay, as we have the 40 grade. So this is not the proper design. Now let me guide you for steel reinforcement dia and its spacing. Guys, you can see here main bars and distribution bars. Okay, the dia is 10 millimeter, spacing is 6 by 8 inches. So 6 inches by 8 inches. This is single mesh. On the top of this they will provide the other mesh. Then the spacing will be 3 inches by 4 inches. Okay, because this is single mesh, on the top of this they will provide the other mesh. Okay, next guys, you can see after completion of steel reinforcement singly and doubly mesh, they will use concrete cover. Okay, for this steel mesh. Okay, next guys, you can see here again they provided here the lapping, because this is floor beam. So here at the distance of L by 4 they already placed the lapping. Look at here guys, so this is lapping. Okay, so this is not good. That's why, because at the distance of L by 4 we should provide crank bar or extra steel rods to resist negative bending moment. As you can see here, now here this length is about 20 feet and 9 inches. Okay, so from that column center to that column center, so this length is about 20 feet and 9 inches. So if you see guys here at the distance of L by 4, where is L by 4 or L by 3? But I will tell you about L by 4. So from this center of column, at this place they should provide crank bar or extra steel rods, but they didn't provide and they will not provide. That's why, because already they placed here, so the cutting length of this steel rod is 20 feet and 9 inches. So this is not important to provide lapping here. Okay, this is not the proper place to provide lapping at this place. So this is one of the big mistakes. So therefore I am telling you, if you are working on construction site, so don't provide lapping at this place. Lapping should be provided after L by 4. This is the place to resist negative bending moment. Okay, due to negative bending moment at this place, it provides cracks. To resist cracks, provide crank bar or extra steel rods or bent up bar. Okay, so this is very important. Next guys, you can see here this is floor beam construction. Okay, this is end of the beam. You can see at the bottom we have 3 steel rods, at the top we have about 4 steel rods. That's why, because 2 are extra steel rods, but they didn't provide any development length at the end of the beam. Development length is very important, guys. You can see here they didn't provide any development length. So therefore I'm telling you, provide the development length which can make a good bond between steel and concrete. As you can see, this is the other beam, same design you can see here. Okay, the bottom steel reinforcement should be through to the upward side, and the upward side or the upper portion steel reinforcement should be going to the downward side. Okay, but they didn't provide here, because this is the important part of steel structural design for floor beam or plinth beam. Next, guys, you can see here, this is floor beam design. We have 3 steel rods at the bottom, 2 at the top. Okay, dia is 16 millimeter or 6 number of steel rod. You can see here we have 2 extra steel rods at this place, which I have already discussed. It is also important at this place, and they provided lapping here. Okay, so here we have negative bending moment. As you can see, this is the span between these 2 columns, okay, which is about 14 feet and 9 inches or 14 feet. But at the distance of L/4, they provided extra steel rods. These are 2 extra steel rods. These extra steel rods should be also making as a development length at this place. Okay, same design you will find here at this place. That is end of the beam. This is at the center. So therefore at this side L/4 you can see the extra steel rod. Also at this side you will see, at same distance you will see the extra steel rod. So let me show you here, guys. You can see, okay, here we have 1 extra steel rod. Okay, so here, guys, you can see at the distance of L/4 you can see the spacing is about 5 inches, the stirrup spacing. After L/4 you can see the spacing is about 8 inches. Look here. Okay, and the dia of lateral tie is 8 mm. Okay, you can see our 3 number steel rod. Hooks are bent on 90 degree. It should be provided on 135 degree, especially in floor beam or in plinth beam. Okay, so it resists with earthquake load. Okay, this is our CC column. Okay, here you can see they provided extra steel rods at side bars. Also, guys, you can see we have 2 side bars. One is this one, that is the other one at the middle, you can see here. Okay, so I'm trying to guide you for technical terms which I have already discussed in front of you. The size of the beam is 15 by 12 inches. Depth is 15 inches without RCC slab, and width is 12 inches. Okay, you can see this is the retaining wall.